Hello, sir.
Hello, Bhavna, am I audible? Hello, Bhavna, is it audible?
Yes, sir.
Alright, Bhavna, so I will just sharing my whiteboard. Got that right? Alright, Bhavna, so in the yesterday's class, till I think I covered which unit vector we discussed, is it?
Yes, sir.
Okay, so today we can go with the displacement vector, right? And unit vector is the last discussion. Yes, yes. Okay, Bhavna, let's look. If I ask you to calculate modulus of any vector, basically magnitude of any vector, calculate magnitude, how you can actually calculate magnitude of any vector. One way is if assume if a vector is given in a form of, let's say I'm taking a vector um, A. This vector is nothing but right now 5 times of I. Understood? So you must be knowing that if I have to make this vector in the plane, it will be looking like this. This is my coordinate plane. Okay, assume this is my coordinate plane, right? So how your this vector will look like? A vector will look like you are sitting at this particular point. This will look like this. From center, you have to go with a 5 magnitude, right? Let's say this is the 5 magnitude. In which direction? I direction. So this is your value. So here, if I ask you, Bhavna, what is the magnitude of this vector? You will directly say, sir, the magnitude is 5. Is it?
Yes, sir.
Okay. X, Y, and Z. Assume I have another vector b and I'm writing it as 3 times of I plus 4 times of g. Now how it will look like? Magnitude is nothing but the exact value. Exact magnitude value. What is the exact length amount? So I will simply say that 3 on the I, basically, let's say this is 3 meter on the y, basically 4 on the y. So 4 on the y, and somewhere around, let's use different color for this. Okay. And 3 on the x. Yeah, you can see 3 on the x-axis and 3 on the y-axis. You can look at like this. So this will result to you this vector b, where it is reaching finally at this stage. Go and at this point, and from bottom this point. So I can simply say that this is the b vector. Can I say this? Can I say this, Bhavna? This is the vector b.
Yes, sir.
So this will be 0, 5, 3. Okay, this is 4. This arrow, this is another arrow. So this is your vector v. Okay. Alright. So what is the magnitude now? Now, if you see the actual length, what actual length is the magnitude. So I can simply say that it seems like this is a perpendicular. If I have to calculate the actual length of this b, what it will be? It will be nothing but, if you see, this is nothing but like this condition, right? It is given a, b,
Yes,
s. So I can simply say that c is nothing but a squared plus b squared. 100. So here also I can simply say that B magnitude will come up as 3 square plus 4 square of 100. Okay. Now let's go into a bigger picture. Okay, I'll just copy the whole thing.
So is it 5?
What happened? Which one? Yeah, is it? That is fine. That is fine. That is fine.
Okay.
So I will write this fine. Fine. Okay, got it. Now another vector. Let's say C. I will introduce 3 square 5. Okay. Something like what I can make it. Three vectors whose sum should be real number. Okay, leave it. Assume one vector is 1, basically I cap, plus 2 j cap, plus 7 k cap. Okay, these, let's not put 7, make it 4 k cap. Here, sure.
Yes.
Look at the 9 after this, so make it 9, 16 plus 45, 16, okay, make it 4, 1, there's another third number, value of 9, 8, then I will make it shift, the 1, 8, okay, yeah, now it's fine. Use 4 over here, but that need to be the key. Okay, that's fine for now. Let's take this vector itself.
Okay.
Remove this. Basically, what we did is, I start in the first case. I took the 1D vector, basically only having either x, y, z, whatever direction you want to take. So you can see in that case, I have the whatever the value given is, that is the magnitude, right? Then I came up to in the
Yes.
second case where the magnitude, where the vector is given into two dimension, right? So in that case, you can figure out the magnitude is in this way, right? In the third case, I'll having a 3D picture x, y, and z. How we can come up with a solution in this case also? That is also same way. Like um, okay. So assume this is the first point. That's the color I will do. In the x, how much is the distance I have to take? Just one. Okay, let's take it. This is one. In y, how much distance I need to take? That is 2.
2.
Okay, so I might be calling this as a 2 distance. In y direction, how much I have to go? In y, basically 4. So I'll start from there and come up with this 4. That's it. So you know that the vector, final vector will be coming up somewhere around here. If I just make it like this, basically from y level, this will be the thing. In x, in z, actually, this will be the level. We will match all of them. Okay, the point where all of these meets in this way, and in x, basically, yeah. For this, I have reached x. In x, you have to reach this way. So I'll be going upside to match this value. Okay, it is directly lying with this value. Just a second. Let's increase the length a little bit so that they don't come up at the same level. That's the thing. That's fine, I think. Um, it doesn't looks nice. Okay, so Bhavana, you can simply see this that these were the lines where we were heading in this way. I just made it like a square, although it is actually not. So you can assume it to be the from this point. This is the final length. Okay, I just changed little bit length. So if you see in the x-axis, what is my length? That is one, right? So
Yes.
this point is one. In y, what is the length? That is two. It doesn't look like two. This all the things look nearly same, and this is four. Okay. So what is actually my magnitude? If you just figure out the real vector is this, from this point to this particular point. Okay, understood? Why? Because it has all three lengths. It has displacement in it. This x direction also, in your z direction also, in y direction also. So how we can compute the magnitude? You know that each of them are perpendicular to each other, right?
Yes.
Can I say? So three options are there how you can compute the final magnitude. One way is just let's say this is the x and y plane, okay? And the vector will be coming out outside. Might be this. So its one projection will be on the x and y axis, right?
Yes.
So if you can just see that this is the projection on the x and y axis. So let's say this is y, this is x. If I calculate the x and y, how I can calculate this value? You know this is nothing but the hypotenuse for the x and y. So I can simply calculate by this by doing x square plus y square under root. Can I?
Yes, sir.
Now you can say I have got this value. Also, this is the z, right? This is the motion, or you can say the length in the z axis. You know, this is also perpendicular. So, can I say this is z? To calculate this one, I can simply do that. Whatever this value square of it, this will come out as this, plus square of z, come out as under root. I will get this value. Can I say this?
Yes, sir.
So, finally, if you see what I am going to get is this magnitude, whatever the magnitude is, its projection on this basically, like this. Joining this one, this will be nothing but x squared plus y squared. Okay, if you look projection on this value, maybe this is the projection, so it will become y squared plus z squared, and projection on this value basically this is the value. This will be nothing but x squared plus not this actually. This and this are the same projection on this level. Okay, this is nothing but what is it? X squared plus z squared. Clear? Just look at this and let me know if you are clear with all these three things. Okay?
Okay, sir.
Look, if you have taken projection of this is the thing, right? So what you have to do to calculate this, you can just simply say that okay, this is the perpendicular. So go on the y and do it with the y. You will get this. Okay, final answer, right? Under root of it.
Okay, sir.
If you take projection and this, so you can see you have already covered x and y. What is the third dimension to cover? Y, z basically. Go in the z, calculate the value. You can see all of them same answer you are getting. Okay, just the way is different.
So basically,
And
when three magnitudes are given, the formula is like under root of x square plus y square plus.
no, it is not the same magnitude. Look, I have to look out the magnitude of the final vector, right?
Yes,
What you
sir.
can do, you just went to a single dimension first. Let's say this is x, okay? Then you cover the second dimension too. Okay, this it's up to you which dimension you want to take as a first, which dimension you want to take second. So when I do
Okay,
this,
sir.
the magnitude whatever I'm going to get is 2. So now if you say I want to extend in the z, so you simply know that whatever the value I had got this will be like this itself, but it is also extended here till here. It means what will be the final value? It should be this, right? Can I say
Yes,
this?
sir.
And if you see that this plane is perpendicular to this, so I can simply say that this is also perpendicular to this. Isn't it like this condition again? I have got it. This is a perpendicular.
Yes,
This is
sir.
the y plane, z basically. This is the no, this is the z basically the extended part, and this is what I have got the result of x square plus y square, right? Understood? The
Okay,
same thing
sir.
happen in all conditions. For example, I went in Y first, okay. Then I have chosen to go for the Z. So you know the resultant of this will come out as this, right? Now you say I have to
Yes.
extend in the x direction also. So extended mean to say this value, this vector is coming out at some point here, right? Yeah, this level basically. This should be upper in the y, the same level should be the y, and same level of the z. Clear? This should be
Okay,
here
sir.
somewhere. Okay, so because you have calculated this, you know this x length also. So this final length you can again calculate. Understood?
Okay, sir.
Okay, I don't have a. If I reshare the screen, so that's okay. Understood the crux of this thing. You can apply it using some 3D shapes. Okay.
Okay, sir.
So finally, you have got the idea how you can calculate the magnitude, whatever the dimensions you have given, do the
Yes,
square
sir.
of all of them and put under the under root. Okay.
Okay,
So
sir.
I have to remove all this. So finally, this C magnitude will come out as what is it? 1 square plus 2 square plus 4 of square and 4 of square and under root. So what is this comes out at? It is like 16 plus 4 plus 1, that is 21 of 12. Okay. So finally I can see if I have to calculate magnitude of any vector, a vector. Okay. If my a vector is written in the form of ai, basically, a1 uh, I plus a2 b, this is j vector basically, plus a3 of k vector. Okay. Then how I can calculate my a vector magnitude? It is nothing but a1 square plus a2 square plus a3 square. Got it?
Yes, sir.
This is the thing. And why this was very easy for us to do, because this I, j, and k all were perpendicular to each other. Understood?
Okay, sir.
Assume another case I give you. For example, a vector a is written in the form of vector b vector plus c vector. Understood? And I ask you calculate the magnitude of this vector. Now, how your vectors are looking like? Assume just in xy plane, okay? Just in a xy plane. This is xy plane. This is xy plane. Okay. How this b vector is fitting? B vector is this, and your c vector is this. Okay. Got it? Even
Yes,
though
sir.
you okay, the problem is this b and c are itself some form of ing. Is it?
Yes, sir.
We don't know. In the previous case, what happened is I knew that this b, let's say this was the b vector, and it is nothing but this thing. In the previous, if you say the first thing which you take, this was my b vector itself, and this was my c vector itself, and I know, okay, I know the magnitude, so I can simply go and get the. Uh, I use
Mhm.
Pythagoras theorem directly, but here I can't do, because this a and b are are themselves in the form of I, j, maybe k also, right? Because here I just took the 2D plane, so if I do the k, there may be possibility that b is written in the form of k also. K have a k magnitude. Okay, so how we can solve this? These things come up with a something called resultant vector. Okay? To calculate this, we have to come up with something called resultant vector, which we will be looking after some time. For not now, not for now.
Okay, sir.
So I think now you are clear with what is the magnitude vector, like what is the magnitude, right?
Yes, sir.
So if I give you a vector, let's say, given a vector, let's say, what vector you can take. Okay, let's say a vector is given with 4 of I plus 2j plus 5k. Okay, calculate the direction. You know what is the direction? Direction is nothing but the unit vector, right?
Yes, sir.
For any vector, unit vector is the one which suggests the direction. So I know this is my vector, which is represented in the form of I plus 2j plus 5k. It means, what does this mean? This whole thing can be represented as two things, that is a magnitude plus a vector, right? Basically this unit vector. I have to calculate this. How I can calculate this? You know very well. I have given a this vector. I can calculate this vector, and if I divide a vector divided by a magnitude, I am going to get a
A
unit
cap.
vector, right? So a cap. So what is the a magnitude in this particular case? This comes out as 16 plus 4 plus 25. Yeah, that is fine actually. So this whole thing comes out as 45. Clear? Done. So you can simply say that my unit vector comes out in this particular cases. Um, Whatever the magnitude, keep it as it is. Not this. Actually, we have to divide by zero, right? So 4i plus 2j plus 5k. Okay. Divide by under root of 45. Divide by under root of 45. Divide by under root of 45. So if you see carefully, this is the unit vector. Okay, this is the unit vectors component in x direction, unit vectors component in y direction, and so on. Anyhow, if you want to calculate, okay, you know very well that a unit vector always has a magnitude of unity, right?
Yes, sir.
So even if you try to calculate this, you can simply know that, right? When you have to calculate, if I ask you to calculate magnitude of this vector, what it will come out? Individual square of each of them and then sum, right? So if you do square of this, you'll be getting this. Square of this two, you'll be getting this. Square of five, you'll be getting this. With each of these value, you have a denominator is 45, 45, 45, because square this square will become 45. So it will be like 45, 45, 45. If you take the LCM, 2, 2 will get outside. Sum of this will come as 45. Cancel, cancel again. Finally, you have got 1, right?
Yes, sir.
So we can simply say that a unit vector has a magnitude of 1. Okay? By this thing, we can also prove. Clear?
Okay, sir.
Hello, Bhavana, are you there?
Yes, sir.
Okay, okay. Let's, let's go that significant erase from the picture. Alright, Bhavana. So let's come up to a new term, that is position vector and a resultant vector. Okay? So basically, position vector is nothing but a normal vector. Okay, position vector. First, let's discuss the position vector. Then I will discuss the displacement vector. Okay, what is the position vector? An absolute position of a vector is known as a position vector. Clear? What does this mean? An absolute position. If you see in the upper whatever we have discussed so far, how I will calling this vector. If you see, to represent this vector I, basically phi I was starting from the origin, right? So if I
Yes,
say
sir.
vector, so I'll be going this. So this is the position vector of this, represented by this. Okay, in this particular case, you can see the 3D dimension. I represented this vector as this. So this is the absolute position vector of this particular vector with respect to the origin. Clear?
Okay, sir.
So so I don't think I should be discussing the position vector uh, moreover, right? I should directly go with the displacement vector. Okay.
Okay, sir.
I'll just write the definition. It gives what happened just now. Wait a minute. All the notes got erased. Bhavna, you had noted down those notes or not?
No, sir.
Okay. All right. That was not a very big thing. Okay, because these things has been already erased.
Yes.
Because look, that was a very simple idea. What we were doing
Yeah,
is
just a magnitude.
just a magnitude. Okay, so I'll just
Yeah.
write one formula
Okay.
for the 3D one. That is, if a vector is given as 3i plus 4j plus 5k. Just calculate the magnitude and let me know. I will write it. Till then, I will be making a whole 3D diagram. Okay. So just get the magnitude of this thing. I'll write it over. 5
Under
plus
root 50.
is fine. Last but not the least. Okay, so this is a square type something I made, and it represents all the directions. Okay. So what will be my vector? This is my vector. Clear?
Yes, sir.
So it contains all the directions. You can say x, y,
Yeah.
z, three of three, and in z you have four. Here you have five. So I can simply say that this point, okay, this particular top point, this particular point represents this point represents 3, 4, 5. You know, in coordinate axis we represent any point with this, right?
Yeah.
If I have to,
Yes.
if in xy, if I have to represent this point, what it is in xy plane, so it will be 3 and 4. It
3,
means
4.
3 in x direction and 4 in y direction or something like this. Okay, so similarly here, this point is nothing but 3 in I, 4 in j, 5.
XYZ.
This point is nothing but 0. This is x axis, right? 3, 0, 0. This point is nothing but 0, like you are not in any x-axis. In 4
Yeah.
y, and this is 0. And what is this last part? That is 0, 0, 5. Clear? So
Okay,
that is
sir.
how you have got this thing. Okay, I'll come up. Yeah, this was how much? 9, 16, 25, and the whole thing comes out as 25, 50, right?
Yes, sir.
Under the 50, and we can write it as 25. Okay, I think 5 root 2 should be the answer for this
Yeah.
one.
Yes, sir.
Alright. So finally I can come up to the next thing, that is position between the displacement and the displacement vector. I will be sharing 3 pages. Okay. You can try to solve problem. Like it contains a lot of vectors from problem from the vector chapter. I'm not sure like it contains the problem from the topic we have already discussed by now, but it contains a lot of problem. Okay. So you
Okay,
can
sir.
try, like if you see some problem which on the basis of the topic we have discussed, we can solve it.
Okay, sir.
So yeah, position vector was, what was that? It represents magnitude and direction of vector with respect to origin. Is that clear?
Yes, sir.
Because if you see in my xy plane, if this is my x and y plane, if I ask you what is the direction of this particular point, I can't actually say, okay, how I make this as a vector because I'm taking it with respect to this particular point. Then I only say, okay, this is at this direction. Assume I'm looking at okay, my point of, what I can say, my origin is this, right? So you can see my direction has got changed, is it? Understood the point? So this
Yes,
is my
sir.
reference point. Okay, if so here, when I say position vector, my uh, I'll be representing a vector with a reference as an origin. Because if I change my reference, my direction is going to change. Let's say this is vector, you can say it is perpendicular. This is has some angle. This is 0 degree angle. So that is the vector.
Okay, sir.
So it's good. X and Y position vector. Okay. Alright, now what is displacement?
Displacement is the shortest distance
Short distance. This is what
from the
displacement
initial
vector will
point.
look like. So what is displacement vector is basically when I say what is the displacement vector is. Let's say this is my 2D plane. Look, the things got same for the 2D and 3D of itself. Okay, but it's an easy option to study the 3D because we are in the. It's easy for us to visualize the 2D as compared to 3D. Okay,
Okay, sir.
assume I have two vectors. Let's say this is the initial position I had. Okay, just assume this is my one vector. A, okay, now you know what is displacement. Displacement is basically shortest distance. Let's say I was starting here and I moved whole of the distance. Like I moved from this point to this point to this point and randomly like whole area I covered and finally I ended up here. Okay. So you know if I ask you what is my displacement, you will simply say that initial point and final point, right? So I can simply say
Yes.
this is my final point, this is my initial point. So what is my displacement vector is the vector which goes from initial to final direction. Clear? Understood? So in this case, this is my displacement
Okay, sir.
vector from A to B. A to B. This arrow works is very important because if you made arrow from here to here, it means this value represents a displacement vector from B to A, not from A to B. Okay,
Okay,
because
sir.
vector is all about the direction, so we can't compromise directions.
Okay, sir.
So you can write this as another vector V. Okay, let's make it as displacement vector A to B. Okay. So what is displacement vector? It is nothing but it is nothing but wherever the final point, that is B vector, minus A vector. This will give you the displacement vector. Okay, that is clear.
Okay, sir.
Okay, if you see carefully how this equation looks like, isn't it? If I resolve it, it will look like A vector plus SAB vector gives you the B vector. Look, just this one, rearranging this equation.
Yes.
Look, for displacement part, we are already done with this and this, okay? Now further, which I am going to explain, that is the resultant vector, okay? So if you see,
Okay, sir.
I am just replacing this SAB with something called B vector and B with a C vector, okay? I'll just make the same figure again. This is your A vector, I'm making here itself. This is my B vector, I'm making here itself. The new B vector, okay? Which is this? This as a B vector. If you see, the tail of this SAB was joined with the head of A, right? So I will just reverse it for a while. Wait, I had to move it. Look now, this is my A vector. Okay. If you see S, like this was a tail, right? So I can make it like this. And the third one was joining the tail of A and head of this. So what we have got, Bhavna, that is A vector plus B vector plus C. Can I say that? And we have already known this relation, right? What was the relation here? We already know that A plus B is equals to C. Can I say this?
Yes, sir.
Uh, Look, I will erase all this part because this is what we are discussing right now. It's not a part of displacement vector. Okay. So if you see, if any condition, basically, if I ask, apart from this, if I generally ask you, what is the A plus B? So this is going to give you the resultant vector. Okay. Understood? What is that resultant vector? It is this. If you
B.
join the head of this vector, this A vector, with the tail of this vector, then the resultant vector is the vector which will be joining the tail of this vector and head of this. Basically, what are the available points? If you see, if I join head of this to the tail of this, so what are the available points? Are this head and this tail. So I will join this and I will get the
Yes.
resultant vector. Understood?
Okay, sir.
Every time is it not necessary for me to make like this. So what I can also write this, Bhavna, you can simply say that this is a B point. I will try to move it from here. Let's see if I can. I can't actually. I have removed this vector. Bhavna, if I delete this vector from here, and if I just take the same vector like this B, do you think will it make any difference if I place it here? Look, earlier it was placed here, right? No, I don't want to join actually because it will get joined into something here. Okay, you can see earlier it was here like this, right? If I
Yeah.
keep it like this, will it make any difference? Because
Yes,
if
sir.
you see, no, it won't be. The reason is, what is the magnitude? Did I change the magnitude of B?
No.
Did I change the direction of B?
No.
So should this equation need to be changed? Because
No.
B is still the same, A is still the same, C should still be the
Yeah.
same, right? So we can simply say that if I keep this like this, even if I keep this like this, it won't make any difference, right?
Yes, sir.
Okay. So you must have got the simple thing that if this, this vector is coming out to be the resultant of this and this vector, okay?
Okay,
Understood?
sir.
So this is what we call as a resultant vector. I will remove all this because we will study this as a part of resultant vector.
Okay, sir.
And the first part of the notes has been already removed from the question, so you will get only two things to see. All right, Bhavna, that's all for today's class. Okay, I will share you the problems. Maybe
Okay,
you
sir.
can try it. Yeah, so
Okay,
that's
sir.
all. You can end the session by yourself. Till then, I
Okay,
will
sir.
close.
Bye, sir.
Goodbye. What is it? Magnitude I'm on to check.